In this video, we will be studying about mathematics.
Students, I hope you have understood the concept of factors and how to factorize a given number into its prime factors by vertical factorization method or horizontal factorization method. Now let us move forward with our topic. Students, you are familiar with HCF and LCM of positive integers. You have done this topic in your previous standard. Now let us look at the method which we used in your previous standard to find out the HCF of given numbers. Now let us consider two numbers, say 28 and 42. Now, in order to find the HCF of these numbers, what we did was we first list out all the factors of each of these numbers. So, first we'll list down all the factors of 28. Factors of 28 are 1, 2, 4, 7 and 14. Okay, and 28. The number itself is also the factor. So factors of 28 are 1, 2, 4, 7, 14 and 28. Similarly, we will list down the factors for 42. The factors of 42 are 1, 2, 3, 6, 7, 14, 21 and 42. So these are the factors of 42. After this, what was done is we found out all the common factors. So we listed down all the common factors of these two numbers. So common factors. So the common factors are 1, 2, 7 and 14. Okay. Now in order to find the HCF, we selected the highest of the common factors. So the common factors are 1, 2, 7 and 14. The highest common factor is 14. So HCF is 14. So this was a method used in the previous standard to find HCF of any two given numbers. Now in this standard we are going to find out HCF using the prime factor method. By using the prime factors. Now let us see how to find the HCF of these two numbers using the prime factor method. So I have got 28. What I'm going to do is I'm going to write down its factorization. I'm going to factorize 28 into its prime factors. Okay. Now I have an understanding that you know how to factorize the numbers. Okay. So let us factorize. So 28 to 14 to 7, 7, 1. Now once I've got this number 1, I can stop factorization because that indicates the end of factorization. So 28 is written as 2 multiplied by 2 multiplied by 7. So we have factorized 28. Now let us factorize 42. 2 will 21. Then you have 3, 7, 7, 1. Again, cannot factorize further because we have reached 1. So 42 can be written as 2 multiplied by 3 multiplied by 7. Okay. Now, in order to find the HCF, what we are going to do is we are going to check the common factors. So HCF. So let us see the common factor. We have a 2, 2 and a 7. multiplied by 7, that is equals to 14. So HCF of 28 and 42 is 14. So see students, the method used in 6th standard and this is the method used now. So we are going to find out all the HCF using this method, and this I think is much more easier than this method. Okay, so let us solve some more examples using this method. Okay, let us find out factor HCF of 51 and 27. So 51 and 27. So let us factorize 51 and 27. So I have got 51. 51. It doesn't go in the table of 2. It will go in the table of 3. 3 ones are 3 sevens are. 17 is a prime number 1. So 51 can be written as 3 into 17. Now let us look at 27. 3, 9, 3, 3, 3, 1. Okay, so 27 can be written as 3 multiplied by 3 multiplied by 3. So HCF is what? Highest common factors. So common factors we are going to pull out. So I have a 3 over here and I have a 3 over here. So HCF of 51 and 27 is 3. Okay, now let us find out. Let us take one more example. Consider with three numbers. With three numbers, say 25, 15 and 35. 25, 15 and 35. So we'll factorize 25 first. 5 5s are 5 1s are. So 25 can be written as 5 multiplied by 5. Okay, then I have got 15. 3s are 5, 5s are 1. So 15 can be written as 3 multiplied by 5. And you got 35. This goes 5s are 7, 7s are 1. So 35 will be 5 into 7. Now let us look at the common factors. Now when you are looking at the common factors, understand students, the factors should be common for all the three numbers. For all the numbers, here we got 3. So all the numbers for which you are finding the HCF, the factor should be common. So I have a 5 over here, 1 5 over here and 1 5 over here. So HCF is 5 only. You are going to write only 5, not 5 into 5 into 5, only one time. So HCF over here is 5. Understood students? So students, I hope you have understood how to find out HCF by using the factorization method. Now as you get more and more numbers, in order to find out the HCF, the more factorization you have to do, and this becomes at one time a bit of a tedious method. So what we can do is we can combine all the three numbers and find the HCF. So let us consider the three numbers, okay, and we'll combine and we'll find the HCF. So I'm not erasing this part. What I'm going to do is I'm going to continue with this part over here. Okay, so 25, 15 and 35. Okay, now in order to find the HCF of these three numbers, what we are going to do is, very first thing we are going to see is that we are going to take a number which can divide all the three numbers. Okay, we are going to take a number which can divide all the three numbers. So the first number which I am going to take is 5. Okay, 5. 5 5s are 25, 5 3s are 15, and 5 7s are. Now if you notice, you cannot further divide any of these numbers by a common factor. Okay, so we cannot go further. So we stop our factorization at this point. Where have we stopped the factorization? Where we cannot find a common number which can divide all these three numbers. So whatever number you have over here is your HCF. HCF is 5. See, HCF is 5. Okay, now let us solve one more example of this type. Consider the three numbers 60, 12 and 36. 60, 12 and 36. So what we are going to do is we are going to find the HCF of all these three numbers by factorizing them together. So let us factorize these numbers together. So I have 60, 12 and 36. So the first step is find a factor which can completely divide all these three numbers. So the smallest prime factor which we are going to check is 2. So 60 can be divided by 2, 12 can be divided by 2, and 36 can be divided by 2. So I've got 2. So 60, this becomes 30, 6, and this becomes 18. Again, let us check for a common factor which can completely divide the three numbers. Again, 30 can be divided by 2, 6 can be divided by 2, also 80. So 2. So this becomes 15, this becomes 3, and this becomes 9. Okay, now none of these numbers are divisible by 2. So which is the next number we are going to look into? That is 3. So 15 is divisible by 3, 3 is divisible by 3, and 9 is also divisible by 3. So 3. So you got 5, 1 and 3. Now look at these three numbers. If you look at these three numbers, you cannot find a common number which can completely divide these three numbers. So our factorization stops at this. So the HCF is, we'll look at this numbers over here. HCF is 2 multiplied by 2 multiplied by 3, that is equals to 12. So the HCF is 12. I hope you have understood this method of finding HCF by factorizing all the given numbers together. You can use the same method even if you have got two numbers to find HCF. Two numbers, three numbers, four numbers. You can use this method for finding out the HCF of the given numbers. Okay, students. Other than the factorizing method to find the HCF, this year we are also going to study about one more method for finding HCF, that is by using the division method. Okay, now if I have got two numbers, say 24 and 42, 24 and 42. So in our method, how will we factorize it and get it? See, we can club them and factorize it, say 24 and 42. So HCF is, so you'll get 2, you get 12, and this becomes 21. Then you have 3, this is 4, and this is 7. We cannot further divide these numbers by common factors. Okay, So our HCF of 24 and 42 is 2 into 3, that is equals to 6. Okay, so this is the method which we used to find out the HCF. Now let us use the division method. Now, while solving or finding HCF using division method, always remember we are going to only use division method for two terms. We don't have to use it for more than two terms. Okay, for two numbers given. Now for the numbers 24 and 42, let us use the division method to find the HCF. So while doing the division method, you have to always divide the bigger number by the smaller number. So let us see which is the bigger number. 42 is the bigger number. You're going to divide 42 by 24. So 42 divided by 24. Now 42 divided by 24, start dividing. So 24 ones are 24. So I have 24 over here minus 8, 18. Now once you reach over here, you do not need to further divide it. What you're going to do is you're going to take this 24 and you're going to divide this number by 18. So I'm going to write 24 over here. Okay, so this 24 has come over here. Now again 18 ones are 18. Okay, so when you divide this, how much you get? 14 minus 8 is 6. Okay, now again I'm going to divide this 18 by 6. Now 6 3s are 18. Now once you reach this 0, once you get the remainder as 0, you stop your division. The division stops. Now you are going to check the divisor over here, the last divisor. What is the last divisor? 6. This last divisor 6 is your HCF. So your HCF of 24 and 42 is 6. So HCF of 24 and 42 is 6. Understood what we have done? We have divided the greater number by the smaller number. Whatever remainder we got, what we did was we divided this smaller number by the remainder. Again, whatever remainder we got, we divided this number by the remainder. And once you reach 0, you stop the division and the last divisor is your HCF. The last divisor is your HCF. Okay, let us solve one more sum. I'm going to solve this from your practice set number 12. Okay, I hope you can solve the first sum. There is a list of sums in the practice set 12. The first one is to find the HCF. I think you can solve those sums by yourself by using the factorization method. I'll be solving question number 2. Find the HCF by division method. So we'll look into the first sum, that is 275 upon 525. 275 divided by 525. Okay, so division method, the bigger number 525. 525 divided by 275. Okay, this is the first step we did. What is the first step? Divide the bigger number by the smaller number. Now 275 ones are 275 minus 0 5 250. Now what I'm going to do, I'm going to divide 275 by 250. 250 ones are 205 0. So this becomes 25. Okay, divide this by, divide 250 by 25. 25 tens are, so once I have got 0, our division stops. Okay, once the division stops, so HCF is equals to 25. So HCF of 500 and of 275 and 525 is 25. Okay, now what you're going to do is you have to write this in this format: 275 upon 525 is equals to 275 divided by 25 upon 525 divided by 25. So this is 11 and this is 21. So this is going to be your final answer. Okay, 275 and upon 525. So how do you reduce it? By division method. How you're going to do it? Divide the greater number by the smaller number until you get the remainder 0. Okay, once you get the remainder 0, the last divisor becomes your HCF. So your HCF is 25. So you're going to divide the numerator and the denominator by 25 and reduce this to the smallest factors, that is 11 upon 21. Okay, now I hope that you will be able to solve practice set number 12. That will be your assignment for the week. Solve practice set number 12.